Hello, in this session we will discuss about composite beams and construction stages in ADA. So we can build the girders of bridges with steel section and concrete slab on top, or any kind of section with concrete slabs. So to start the project, we need to define our construction stages, but we need to be sure that our project or our beams are not short during construction. So if they are not short, we need to define the construction stages on the Composite Beam tab of Project Configuration. And if we don't define the construction stages, ADA will consider the beams as short. So that's the difference between defining the construction stages and not defining them. So if we define construction stages, our beams are not short. So in the next stage, after defining the project configuration and construction stages, we will create this slab for the composite beam. And after that, we will define the composite beam itself and the properties. Next will be the definition of load cases and load combinations. And finally, we will discuss about the results in ADA and also stresses in the composite beam. So I'm going to start the project right now. So we always click on new project. Go to three-dimensional isometric view. Afterwards, we always go to File and Project Configuration. So you can put the name or other specifications of the projects in this window. That right now I'm going to leave it as blank. Our preferences are all right for now. The analysis, we are going to do nonlinear analysis, and the other default values are fine. And after that, we will go to Composite Beam tab, and because we are going to do construction stages, we need to define them here. So I'm going to put the check mark here. So it will be a project with steel or concrete composite beams. And I'm going to activate the first stage, steel frame, second stage, casting. I'm going to deactivate the other stages because in this project we will not use them, but you can always put the check mark on them and use them to apply extra loads or extra casting sequences. And also here in composite structure, which is the stages that we add extra loads on our structure, I'm going to use stage 6 and 7 and not 8. Also here in this part, as you see, it's about the fatigue. And as you see here, we have different characteristics and properties here to calculate the fatigue in the beam. So I'm going to leave these as default. And here, as you see, we have the N ratio for the long term and short term, that is 3 and 1. And finally, you can also modify this value for non-effective stiffness over original stiffness. So you can always modify these values. For the purpose of this project, I'm going to use these default values here. Okay, next stage will be to define the geometry of my beam. In this session, we will only discuss about the one-dimensional beam, or what they call it, simplified modeling and design, which is we only consider one beam. So to define this composite beam or girder of the bridge, I'm going to define first the nodes. So activate the node mode, Control H, and here I will define the nodes. So node number 1, it will be a support, and the other coordinates will be 0. And node number 2, the end node, it will be a support again, and I will have a 20 meters x coordinates here. So the span of the beam is 20 meters. In the next stage, I'm going to add the member itself. So activate the member, click add icon, and just click start node and the end node. So we have the member properties dialog box here. So I'm going to, as you see here, all of the characteristics and end conditions here on my project, that's okay, and I'm going to leave it like this. And for properties, I will use a W section for the steel section. W1222, and we can check the section properties here in this window. Okay. For the material, I'm going to use an ASTM standard. A57215. The dead load will be used to calculate the self weight of the steel section. And two important options that need to be defined here. The first one is activate the design criteria, because we need to do the design. And also in our composition, we need to change the standard to composite beam, because we are working on a composite beam. And as you see, when I change this, an additional tab will be added here. Because it is an stage construction project, in the advanced tab here, I need to define when my beams will be activated in the project. So because these are the main sections and main beams before casting the slab, they will be activated from stage 1. So we need to define it here at stage 1. Okay, next we need to go to Composite Beam tab. Here we will define the composite section itself. We will define the composite slab studs and other properties. So for the start, we need to define the slab. So right now, as you see, we don't have any slabs defined. To define a new slab, we need to just click here, this option. And here in this spreadsheet, you can define the slab for the composite beam. So I'm going to add a row. You can always enter the numbers directly in these cells, or ADA has the better way to do that. You just click one of the cells here, right click, and click on detail. So you will have the slab graphically here, and it's much more easier to import the values. So I'm going to give the number of 1 to my slab. The material will be concrete 030. The thickness 200 millimeter, for example. We don't have any steel deck here. We don't have hunch. And direction is perpendicular. And total thickness, as you see here, it's automatically ADA put it here as 200. And to define the reinforcement here, we need to go this tab. We define the material for reinforcement. For example, I'm going to use 400R here. For top reinforcement, we are going to use 15M with spacing of 200 millimeters. And the D distance here, as you see here, which defines also the cover of the reinforcement. I'm going to use 167. Also for the inferior bottom one, we will use 15 M, 300. And again, same number. Clicking OK, as you see, it's automatically defined the slab. So you can even modify the numbers here. For example, if I want to change the name for a slab, you can always do it in this spreadsheet as well. So click OK. And if I go to this drop down menu, I will have the slab define slab here. So here we define the slab for our composite section. In the second option here, you need to define the used studs, and ADA will use this to design the studs for shear. So for this example, I'm going to use 22 millimeters. Here it's the effective width of the slab, which depends on the space between the girders in bridge. You can have effective and actual. For this project, I'm just going to use 2.4 meters or 2,400. And actual B, I'm going to define is as the effective one, so they're equal. So QR, as you see here, is a parameter for the shear of in the studs and shear transfer. And if anywhere in ADA you want to get help and online help on the parameters, or you don't really know what's this parameter here, you can always activate the window, which is right now it's activated, and press F1. So ADA's online help will pop up, and here you can check the values in this dialog box. For example, if I'm looking for QR, coming down, as you see here, QR is a fraction of full shear connection, that you can put it here. So for this project, it's 100%. Number of studs per row, I'm going to define it as 2, let's say. And here we have the other options here. Just remember that when you are using construction stages, you need to uncheck this. So, because if you put the check mark here, ADA will use the weight of the slab from the beginning of the analysis. That we don't want it, because as you know, the slab will come and will be casted after stage 1. So always remove this check mark if you have construction stages. And this check mark is for composite properties for analysis. If you want ADA to calculate the composite beam and use it in the analysis, you just put the check mark here. And if you just need to have this section, you need to remove this check mark. The other option that we need to define in this dialog box or tab is the effective composite section at the stage. So we need to define here in what stage ADA should consider our section as a composite. So here I'm going to add define it as stage 6, which concrete is already casted and the slab is hardened. And what you see here at the bottom is the properties of transport section. And ADA used N7.5. And these are the characteristics of the composite section here. Okay, if we check our member, everything is okay here. We have defined it as stage 1. Connections are fine here. And here the steel tab. We don't have any bolted connection here. We are not doing evaluation. And here is our composite beam. So we are okay here. In this stage, I'm going to define the steel specifications for the design of composite beam. So we go to structure, specifications, and steel. I'm going to add a specification here. Let's name it as S6 14 design. So the standard is okay. It's not okay. So I'm going to change it to S6. It will be a design. Section group is USA. And it will be a W. And the material is, as we define in the member definition, is ASTM 50. We can also add a verification, so I'm going to copy it and paste it here and change the name and here we change it to verification. For verification we don't need to use any kind of section because it will use our own defined section from the beginning. So we have defined our steel specifications here. Okay. If you want to check the beam and see it in three-dimensional, we go to View Options or O. In the attributes, we activate the 3D display, and as you see, we have our composite girder or composite section here with the concrete slab on top. You can also have a transparent view. If you go to Graphic tab and activate these translucent surfaces, okay, on, and if I click Apply and OK here, as you see, we have a better view of the section and slab in this graphics mode. Okay, now we need to define the steel properties of our member. So I go to the selection mode, activate members, click on element, go to the steel tab, and here in the specifications I'm going to define or insert our specification here, 6/2014. And also because in our beam we have the top section connected to the slab, I'm going to activate it and put it as continuous lateral support. The other options here will be automatically calculated by ADA. And in this project we don't have any stiffeners, so there will be 0 here. Okay. Next step is to define the load cases. So we have the dead load here. So I'm going to just define it as a 6, and it's prefabricated components, the steel ones, so it will be this. I'm going to add another one as slab. It will be a 6 cast concrete. The other load case is the bitumen. It is a veering surface. And I'm going to add another kind of load, let's say here as New Jersey's. And they are also prefabricated components. So click OK. In the next stage, I'm going to apply the load. So we need to activate the load cases here. The dead load case is already calculated and applied by ADA. As you remember, here we put it as dead load to calculate the self weight, so it's already here. But for the other ones, I'm going to define them manually. For example, for the slab, save the project. Yes. So for the slab, I'm going to double click on the member and add a linear load of minus 1.28. Y, okay. So as you see, the load is applied here, kilonewton per meter. Also, I'm going to define the load from the bitumen. -6. And we are going to define the final one, New Jersey. As -2.5. Okay, the value of loads here are just for demonstration, so I just want to show you how to define loads and other stuff in ADA. Okay, now I have defined and applied my loads here, load cases. Next stage, we need to define our load combinations. So loads, load combinations. We go to definition first because we have construction stages here. And I'm going to add the construction stages here. So the number will be stage 1. We define it as a construction stage. You can use S6 construction stage. The next one will be stage 2. And again, it is a construction stage. I have stage 6 also. And finally, stage 7. Okay. Now that we already defined our load combinations, also we need to define the stage here for ADA to know that which combination will be used on which stage. So this is stage 1, this is stage 2, stage 6, and stage 7. And here we are going to define the loads which we have in our combinations. So for stage 1, we add this. It's only the dead load case coming from steel sections. For stage 2, I have this slab. And the dead load from the previous stage is already included here. So ADA automatically adds up these loads, so you don't need to define the dead load again in this stage. Stage 6 will be the addition of the wearing surface or bitumen. And stage 7 is the new jerseys. So right now I've defined the load combinations, I've defined the factors, load factors, and what kind of load cases are in the load combinations. Right now I'm click OK. And if I check my load combinations here, as you see, they're all defined and I have the load cases here. So now to generate the other load combinations like ULS, SLS, and others, I will use the generator tool. I'm going to use S6 here. We need to add the new ones to the existing ones, so don't put the mark here. We need to check this one. And this option is OK, so I'm going to click Next. So these are the load combinations that ADA will generate. For now, we don't have moving loads or seismic, so I uncheck them. Click Next. And as you see here, I have the load combinations, minimum, maximums, according to code. So if I click Finish, the load combinations are generated here. I have the ultimate state, fatigue, and service. Of course, if we have more loads like moving loads, there will be more of them here. But right now in this session, we're just talking about how to model a composite beam. In the next sessions, we will discuss about adding the moving loads and live loads. Okay. Another thing that we need to do here is defining some construction stages combinations in design mode, because the steel design results will be available for each construction stage if they are defined as ultimate status. So we need to duplicate this and change this status for ultimate to have the steel design for each construction stage as well. So the easiest way is to selecting all 4 of these. You just left click, hold it, and drag down. So they're all selected. Right click, copy, and I'm going to paste them here. So as you see, they're here. We need to change the name, so I will change their name as Stage 1 Design. And we'll change this to Ultimate. We are also Design, Ultimate. Finally, Stage 7 Design, and the status. So we will have the design results for these stages as well. Click OK. Now we are ready to perform the design and the static analysis. So we need to just go to this icon, Analysis and Design, click it, save the project, yes, analyze. So calculation is complete, close. As you see, ADA is decreased the I section because we don't have, and we didn't define any moving loads, so it decreased it. And we always, after doing the analysis, we need to check for load combination summary to see everything is fine. Yes, analysis are okay. And to see the design results, we need to go to View Options, Results, and Design Load Rates. So as you see, ADA has optimized the section and it decreased my already defined section, which was another larger section, and it's economical. As you see, it's on 97% of its unload rate. We can check for diagrams. So again, in View Options, firstly we need to select which load combination we want to check the diagrams. Let's say the ULS1, and afterwards we go to View Options and put the check mark here, for example, for moment around strong axis. Automatic adjustment, and as you see, I have the moments here. For the shear, this is the shear under this load combination, and for the deflection for strong axis, I have minus 77 millimeters for this load combination, or I can always change it. We can check for stage results also. For example, as you see in the stage 1, just dead load of the steel section, I have minus 6 something here, and these are other results for the stages. To check the detailed design results, still design results. We can go to this icon here and double click. So here, as you see, I have the detailed design results for this composite beam. The values that automatically calculated with ADA for bending and axial load design, and also for shear torsion. And here I have the required number of studs for my beam here. It's 56 for the region of positive moment diagram. So this region starts from a 0 moment to the maximum positive bending moment on the diagram, and this is for the -1. So again, if you need to get some help on these or other parameters, you can always press F1, and here in the online help you can have the description here, which says that number of required studs to transfer the shear stress, number corresponding between the 0 moment and the maximum positive moment. So because we didn't define any deflection criteria or specifications, we don't have any results here, but we have already discussed this and how to define this in the previous session. Okay, and also we can view the design results for other stages. For example, if I want to check the design results for stage 1, as you see, it's 5.9. Stage 2, casting sequence. Stage 6. And stage 7. Okay. And again, you have the detailed results for all of that stages. For example, if I want to see the detailed steel design results, I change this drop-down menu to stage 2, double click, and here I have detailed design results for this stage, stage 2. You have also access to complete and detailed design report here, which shows exactly the moments, the governing load combination, shape properties, and here we have the clauses from the code that ADA used to do this design. Another results that you may need to know is the properties of the transformed section. So to have those results, we need to go to the structural mode, double click the member, or you can hit Control H to activate the spreadsheet of the member. And as you see here, we have two tabs here for short-term and long-term properties. So if I check the short term, as you see here, we have the properties of section with n value of 7.5. And here at the next tab, we have the long term with n value, 3n value, 3 times n. And these are the properties of the transform section. Okay. ADA also provides the stresses inside the composite beam, so you can always have the values of stresses in your design in your sections. So to get those stresses, we need to go to results, load combinations, and as you see here at the bottom, I have stresses composite beams. So if I activate this, as you see in this window, I have the results for stresses. So here you can change it to stresses in composite beam. Stresses in composite beam, other points that I will going to discuss it right away. You can check for bending moments, shear forces, deflections, and other results here. Here it is the results from stages and service limit state. So you can check all of the results and stresses in the composite beam. In this part, you can filter the stresses from the section. So let's say if we need to just see top of a steel shape, left, I will uncheck these, and this result, as you see, this is stress. This is a stress in the top of a steel shape in the left or right, which are equal. If you want to have an exact value, you can click on the curve here to have the value of stress. Just double click. This is the length of the member, and these are the stresses in megapascal. Or I can have bottom of steel section, the red lines are the limits for maximum tension and maximum compression. We have the bending moments here, shear force, the deflection under stage 7 or service or stage 1. We had another option in our results here. As stresses in composite beam, other points. To have these points, we need to define them in first stages or in member definition dialog box. So I'm going to show how to define those nodes. For example, if you want to have the stress in specific points here or here on this section, ADA has this feature to define the node first, and it will calculate the stress on that specific point on the section. So to define those, we need to go to structure mode, double click, composite beam, and here, as you see, we have a option here as extra calculation stresses. So as you see, we have different type of sections here. For example, because my section here is an I1, and these are the points here, A, B, C, D, the faces, and these are the coordinates that you need to add here to have your 4 points to be defined. For example, if I want to add a point here, A, and at the final edge of the bottom flange, I need to use it here, A, and I will add a number here as this distance. So before we come here, we need to check that distance here at the properties of section. So my section has changed to W360 to 179, and the bottom flange is B and A, and I will input the A value there. So it is around 174, this coordinate here. So I will add it here. A 174. And you can also add another point. For example, if you want to check this K value here, I'm going to select the K point. And if you pick up this node, want to pick this node, you need to just put 0 because it starts from here, as you see. So K will be 0. So I've defined 2 nodes, okay. Perform the analysis again. Close. Results. Stresses. And right now, if I go to here, stresses in composite beam, and as you see, I have my point 1 and point 2 here, and the stresses are here. You can always zoom in and double click to have the values. In point 1 and point 2 that we have already defined in our section, and you can define up to 4 points to have these stress results. And these are the different node combinations to check the stress for those nodes. Okay. Okay, this was the simple example on how to model a composite beam, an ADA, definition of the section, definition of the slab, beam properties, adding the load cases, defining the construction stages and applying them on the model, performing the analysis and design, and getting the results. So we will need to add some moving loads on this girder also. So the moving loads will be discussed in next sessions, and we may use the same model to add the moving loads and analyze this. So this concludes our session today here. If you have any questions, just let us know in our email address here. Thank you very much.